Alright, let's do the second part. Asking you to calculate the acceleration of the train as it speeds up to 360 kilometers per hour. So 360 is somewhere here, and so I have the time speed up to here. Now it's a simple question. All of you know how to do that. So acceleration is just the change of speed over time. Now just make sure this is in second and this is in kilometers per hour, whatever unit you need to do. I have decided that I'm going to convert time to seconds. Okay, I made a mistake here. No, it's not the time up to 360. The speed is up to 360. Oh my god, I'm sorry. Okay, so 350 is here, 360 here, so going all the way to this point. You need to be very accurate, that you know that, isn't it? So up to 360 is my speed, and then the time is 450. Okay, so I'm just going to convert 450 seconds to hours. That is dividing 450 by 3600, which gave me around, I'm just going to go through that. So this one is 0.1. Yeah, you're right, you got that one. Just acceleration is nothing but 360 divided by 0.125, which is 2880. Please do not forget to write the unit. In this case, this was our unit, not meter per second square, because we converted time to hours. Now let's do the next one. Whether the performance of the train met the specification on that test run. Okay, now this one is trying to see that this acceleration should be completed within 40 kilometers of level track. Now, all I need to do is basically find the area under the graph till this time. So this is my area, okay, all the way up to this time. Oops. Okay, so all the way up to this time, that's my area. So the area is nothing but half times base times height. It's a triangle. The base is 450 divided by 3600, because it is in kilometers by converting as seconds to hours, and the height is 360. So this gave me around, the exact point is 22.5 kilometers. So it is definitely less than 40 kilometers, which is given in the question, hence meets the specification. All right, let's just do the next bit. On a curved track, there is a maximum speed, safe speed. Now, why is that? Why do the curved tracks have maximum speed? Any guesses if you've done it? Remember, on a curve, when anything is taking a turn, they need a centripetal force. Who is providing that centripetal force? In this case, it's a friction that's providing the centripetal force. Can you change the friction? Can a running train change the friction between its tires and the rails? No. So the centripetal force that is available is constant. Okay, it is not changing. Okay, that is available. Where is it available from? It's available from the friction force is constant. So constant. So because this available centripetal force is constant, so my mv square by r should be less than the centripetal force. Okay, should be less than the centripetal force, or maximum it can be equal. Okay, it can be equal. So what we're going to do is say now, because first point, we have a limited centripetal force. Why is it limited? Because the friction force is limited. Now, because the friction force is limited, our mv square by r, which is to be provided by the friction, has to be either less than the friction, or maximum it can be equal. So if they're not equal, my force cannot provide the turning force. My friction force cannot provide the turning force, and hence the train would skid off the track. It would not be able to turn. It would just keep going straight because the friction force is not sufficient. So the maximum safe speed should be able to balance the friction force. That's it. So it tells you that train does not derail. All right, let's just do the next one. When the train travels at 200 kilometers per hour, sorry, the previous one was 4 marks. Let's just add 2 more points. If V is higher, if I spoke about it, I'm just writing it here, F cannot provide, F means the centripetal force of friction cannot provide necessary centripetal force. Okay, so that would provide the second okay, and let's do the next one now. When the train at 200 km/h, the minimum safe radius of curvature is 1800. If the what's the radius of curvature if the speed is 360? Now it's the same question, the previous one. If you understand that what is constant is the friction force, the centripetal force is constant. So I'm just going to write that. So my available centripetal force is constant. This is constant. Now obviously the mass of the train is constant, so my V square over R is constant. It's not changing. So I'm just going to use these two conditions. So V in the first case is 200 and the radius is 1800. This should be equal to 360 squared, and we want the new radius. So just my new radius would be 360 squared times 1800 divided by 200 squared, which when put in the calculator got me 5832 meters. So that's it. Next one. Oh no, that's the last one. That's the last question. All right, brilliant then. So learning from today, first we're going to be doing in 20 minutes sessions. Okay, after every 20 minutes, get up, take a 5 minutes break, walk around, come back in, drink water or whatever, come back, do another 20 minutes of session. Do not do the paper just for the sake of mark scheme or the solution. Do the paper to understand the concept. Zero down. So now note down whatever new concepts you've learned. Okay, and did you remember that you use this one, or the changing magnetic flux produces an induced current which opposes friction force in a turning train, or in a curved path provides the necessary centripetal force and hence is constant. So these are the learnings. Every paper would teach you something. So we're going to now the next video I'm going to make it on 2023. But I'm going to try and make it a little bit technically superior as compared to this one. So sorry if there was the quality of the video is not as good, but I promise you the physics was not that bad. So we are here to learn physics. So thank you for watching, and please message me, like me. Thank you.